So we can add to the list of our fundamental properties of structs is object 1 equals object 2, and that would be obviously the assignment. All right. What else? I think that if you look at pixel and if you look at the date structure, the actual obvious difference between them is the sizes, right? It's interesting how much size this pixel allocates in memory and how much size this date structure allocates in memory. And so the next fundamental thing that you can do with your structures is this. You can, basically, we can do it right here. We can say std cout size of today, which is an object, is, and we can display what that size is by using the Sizeof operator. Okay, so that's yet another fundamental type of the structure, is that you can instantly, and I obviously need a semicolon at the end of the statement, so that you can ask your object, what's your address, but the second thing you can ask your object, what's your size, and the result is returned in bytes. Okay, so if I run this, right, if I say build this, right, if I run this, let's see how that looks like. Right here, if I go edit, right, oops, file properties, make it easier for us to see. All right, I'll use some colors. So if I do this, you see this, the size of today is 12, which kind of makes sense because it is 3 integers, and each integer contributes 4 bytes, right? So 4 times 3 is 12. So the sizes of objects in C and C++ are measured in bytes. How many bytes does an object take in terms of, taking real estate from computer memory, and it's measured in bytes. And of course, similarly, you can actually say that the size of pixel, you don't even need to have an object. You can ask the structure, which is a named structure like this, what's your size, all right? And the value is returned back as essentially as an unsigned integer, and you can without even creating any objects, you can go to the structure and say, what is your size? So here we should then be able to run this, right? And it says the size of pixel is 24 bytes. Okay, so let's see how this is possible, right? So let's just, so it says 24. So this must be 4 bytes, right? These guys contribute 4 bytes each. A float is also 4 bytes. And then, so we have 4 times 5, 20, right? And the character is 1 byte in size. We know that for sure. But what my compiler does on the system, it actually pads this with 3 bytes, because the memory allocation will be faster if 3 extra bytes were added, and altogether the structure was made 24 bytes in size. The compiler just assumes that it says, well, look, I'm going to consume a few extra bytes for you, but your program will run much faster if I pad your structure with some extra bytes. So it makes it not 21 but 24 bytes in size. So sizes are very important, and you cannot theorize about your sizes, because sizes are architecture specific, just like addresses are, and so the Sizeof is a very important operator because it tells you precisely this is the size of your structure, okay? And then, you know, we can rely on that knowledge. All right, so we can say that it's okay to say Sizeof, right, in terms of the fundamental properties of the objects that we can create from our structures, is that the Sizeof object as well as size of your brand new type name, such as date or pixel, that we used in today's presentation, those facilities are available, right? So that says measures sizes in bytes. How many bytes? That's the result. Okay, so these are basically fundamental properties of, we can say, C structs, the structs that came from C programming language. Obviously, C++ took that and said, let's support all of this. Okay, what else can I possibly think of in terms of the fundamental properties? So sizes, addresses, passing them, the dot operator, right? So we can also say that the dot operator clearly is something that we use, like object dot field is the field or data equals value we can use in order to access individual data fields such as X, Y, red, green, blue, and alpha, and of course such as the date. All right, so that's good enough, and of course the final thing that we had seen today was if we have the pointer to an object, right? Such as this pointer to an object as in pixel pointer. Of course, we use the arrow operator instead of the dot. Okay, so you can almost say that if I have birthday and if I have today, I can say take address of, let me just basically copy and paste, right? You can say take address of today, take address of birthday, and then instantly dereference these things, and essentially this kind of tells us that taking address and dereferencing are the two opposite operations. So basically today equals birthday could be done in a strange way by saying take address of today but immediately dereference it, take birthday address and immediately dereference. This is of course nothing to use in real code, but just an idea that essentially taking an address off and dereferencing are the two opposites, the two opposite operations. You can ask anything that has a name, what's your address, and then you can say, oh, let's go to that address and do something with that specific object. So these are the two opposite operations. Okay, good.